Assalamualaikum and good day everyone. So in this video we are going to proceed with the second example of neither function, okay, on how to solve a neither function. So take a look at this example here. You are given a periodic function fx which is defined as x plus 4 and another one is fx is equals to 2. Okay, so the first question is you need to sketch the graph within the range of -3, 3. So before you can sketch within this range, you need to sketch based on this original range here. Okay, so as you take a look at the function here, the first function here you have a variable x. So therefore you need a table of coordinate for the first one. Okay, as for the second function here, this is a constant. So you know that it will be a horizontal line or a straight line. But as for the first function here, if your value of x change, so your fx will also change. So that's why we need to do a table of coordinate. Okay, so for the first function here, let's consider this table of coordinate. Okay, so you will have to consider your x and your fx is equals to, so this is your x, so your fx is equals to x plus 4. Okay, and what is the value of x that you need to consider? At least the first one and the last one here, lower limit and upper limit. Okay, so you need to consider -1 and also 0. So when you have this value of x, so substitute x is equals to -1 into here. So you will have 1 point here. Substitute 0 into here, then you will have another point here. Okay, so therefore you will have 3 here and this one is 4. So you will have a coordinate of -1, 3 and another one is 0, 4. So now we are going to sketch this one. Okay, so first you need the axis, so x-axis and also fx-axis. Okay, so this is your x-axis and this is your fx-axis. Okay, so based on this question, you were asked to sketch from -3 until 3. And as you can see, your original range here, the range is 1, isn't it? From 0 to -1, the range is 1. From 0 to 1, the range is 1. Okay, so therefore you can use 1, 2, 3. Same goes for this side, -1, -2, -3. Okay, for the fx, if you take a look at this value here, this is value of x, this is for fx. So the highest value is 4. So therefore you will have 1, 2, 3, 4. Okay, so what is the first point? So the first point is -1, 3. So x is equals to -1, fx is equals to 3. So you will have this point here. Okay, for the second point is 0, 4. So x is equals to 0, fx is equals to 4. Therefore you will have here. Okay, so your line to connect these 2 points will give you this line. Okay, so this is the first function. Okay, this is the first function here. For the second function, fx is equals to 2. For x between 0 until 1. So you know that between 0 until 1, your fx is always 2. So you will have a straight line here, a horizontal line here. So therefore you will have this line. Okay, so this is your first function, this is your second function. Okay, now after this period of 2L, which means from -1 to 1, this is 2, isn't it? After this period, the graph will repeat itself. Okay, so if this is the first function, the second function, then it will start again with the first function. So where to start? You end up here, so you need to start with the same value of x. X must be 1, but your fx is depends on your fx here. Okay, so you have a point right here. You cannot start here, or you cannot start here. Okay, the last point will be the first point of a new function. Okay, the last point of a function x here will be the first point x for the first function, another function. Okay, so therefore you will have one point right here and another one here. So you will have this line. Okay, and the second straight line will be like here until here. So you will have another straight line. Okay, so settle for the right hand side. So for the left hand side here, you need to start with the second function first, because as we number it, this is 1, 2, so this is 1 and this is 2. So for the left hand side here, you need to start with 2 and 1. Okay, the graph will just repeat itself. You don't need to construct another table of coordinate and plot. No. Okay, just repeat the same graph. Okay, how many range here? It depends on the original function here. Okay, so therefore you will have, so the second one is a straight line. So this is the end point of the first function. So it will be the first point for the new function. Okay, so a straight line here, and this one stop until here. So your new fx is right here. Okay, the new fx is right here, and stop until here. So therefore you will have another line here. Okay, this dotted line, if you think that it is need to do, then you do it. If you think that it will make you sketch the graph more easier, then you can do it. Okay, but please don't do a straight line. If you do a straight line here, that is wrong. Okay, just a dotted line, so that you know, so this is the end point, and where did you need to start with the new fx, but the same x, so here, up here. Okay, so by looking at this original graph here, it is not symmetrical, either the fx axis or origin. So therefore this is a neither function. Why? Because it is not symmetrical about origin or fx axis. Okay, so settle with the first two questions. Okay, so the next one is you need to find the Fourier series coefficient corresponding to the function. So here you already sketch and you know that this is a neither function. So therefore you need to calculate your A naught, your AN and also BN for a neither function. That is why sketching is very important. If you sketch wrongly, then you will identify the wrong function. And when you identify the wrong function, then you will calculate the Fourier coefficient of the wrong function. Okay, so you need to really understand on how to sketch the graph here. Okay, because this is very important. So you need to calculate your A node, AN and BN. So how to calculate your A node here? First, you need to define what is your L. So in my previous example, I already teach you on how to get your L. Okay, first is by taking this value. So this is your L, the highest limit here. Or you know that the periodic function is defined as fx plus 2L. What you have is fx plus 2. This one here. Okay, so by comparing these two, 2L is equals to 2, so you know that your L is equals to 1. Okay, or you can simply get your L right here. This is your L. Okay, so you know that your L is equals to 1. So therefore, your A node is equals to 1 over L, negative L to L, fx dx. Okay, so what is your L? Your L is equals to 1. So 1 over 1 is equals to 1. So negative 1 to 1 fx dx. As you take a look at your function here, you have from negative 1 to 1, but here you have two functions. Okay, x plus 4 and another one is 2. So you need to split this limit. How to split this one? Based on your original range here. So therefore, you will have A node is equals to negative 1, 0. So from negative 1 to 0, what is your fx? So negative 1 to 0, your fx is equals to x plus 4. So you will have x plus 4 dx plus, so another one is 0 until 1, your fx is equals to 2 dx. Okay, take a look before you proceed. This one is your lower limit, this is your upper limit. So as you take a look here, this is your lower limit and this is your upper limit. So this is already correct. So another things that you need to check is this point must be the same value. Okay, then only it will be a continuous. Okay, so negative 1, 0, 0, 1. Okay, how I get this one? Based on this original range here. Okay, so therefore we can proceed on solving this one. Your A node is equals to, so integrate this one will give you x squared over 2 plus 4x 0 negative 1 plus 2x 1 0. So next apply upper limit minus lower limit. So 0, so you will have 0 here minus, so lower limit here will be, so negative 1 squared over 2 plus 4 negative 1. So this is for the first function. For the second function here plus, so upper limit 2 minus 0. So therefore you will have 1 over 2 here minus by 4 will be negative 7 over 2. So negative negative will give you positive 7 over 2. So 7 over 2 plus 2 will give you 11 over 2. So this is your A node. Okay, so now settle with your A note here. So next you need to calculate for your AN and also BN. So take a look at this formula here. Okay, for A note you just consider fx. For AN, your fx need to be multiplied by cos function. For BN, fx need to multiply by sine function. Okay, so when you calculate your A note here, you already split your function, isn't it? So by using the same limit here, you just, for AN, you just multiply this function with cos. Okay, for BN, you multiply this function with sine. Okay, so therefore for AN here, you will have -1, 0, x plus 4 cos n pi x over L. Your L is equals to 1 dx plus 0 to 1, 2 cos n pi x dx. Okay, so over 1. So without this one also can, because over 1, so we can just ignore it. Okay, so take a look here. For the first function here, you cannot integrate directly. Why? Because you have a multiplication of two functions. This is polynomial and this is trigonometric function. But for the second function here, this is direct integration. So what you need to do is use tabular method first. Okay, so you will have a tabular method here. So this is differentiate and this is integrate. So the first value is, so x plus 4 cos n pi x. Okay, so differentiate x plus 4 will give you 1. So integrate cos will give you integrate cos will give you sine. Okay, so you will have sine n pi x over, so differentiate the argument inside here will give you n pi. Okay, so the last function here, this is 0. So integrate sine will give you negative cos n pi x. So again over with n pi. So now will become squared. Okay, why squared? Because this is n pi. So when you integrate sine, you get cos, and you differentiate the argument inside here, n pi x will give you n pi. So n pi multiplied by n pi will give you n pi the whole thing squared. Okay, so therefore this is your result for your tabular method here. Okay, you can choose either to solve this one separately and this one separately, then combine, or you can just substitute all this one right into here and integrate this one. Okay, so it's up to you. Okay, so if you want to solve it separately, then I'm going to solve this function first. Okay, so therefore I will have -1, 0 x plus 4 cos n pi x dx is equals to x plus 4 over n pi sine n pi x minus minus, so you have plus 1 over n pi squared cos n pi x. So now this is your function, the answer. Okay, for the limit from 0, upper limit 0 and lower limit is -1. Okay, so now we need to consider upper limit minus lower limit. Okay, so your upper limit is 0, your lower limit, the upper limit is 0, your lower limit is -1. So therefore you will have, so the first value here, so when you substitute 0 into this one, this one, this one, so what will you have is 4 over n pi sine 0 plus 1 over n pi squared cos 0. So this is your upper limit, minus, so your lower limit -1. So you will have 3 over n pi sine -n pi plus 1 over n pi squared cos -n pi. So how to simplify this one? To simplify this one, you need to use this one. Okay, so let's consider this one. So first I copy this one first, so I paste it here. Okay, so sine n pi is equals to 0 or sine -n pi is equals to 0. So therefore this one you can cancel out. Okay, sine 0 is equals to 0, isn't it? So this one also cancel out. Cos 0 is equals to 1. Okay, now take a look here. You have cos of -n pi. So you need to change it to be -1 to the power of n. Okay, so therefore this one is equals to 1 over n pi squared minus 1 over n pi squared -1 n. So here -1 power n, so you can write it as 1 over n pi squared plus -1 n plus 1 over n pi squared. Okay, so this is your A note. Okay, so now what is your Bn? Next you need to calculate your Bn. Okay, so to calculate your Bn here, you need to use this formula. Okay, so now this one is for the first function here, which is from -1 until 0, x plus 4 cos n pi x. So the next one is for the second function here. Okay, don't forget this function. Okay, so for the second function, so you have to integrate from 0 until 1 to cos n pi x dx. So therefore this one is equals to 2 sine n pi x over n pi 1, 0. Okay, take a look here. this n pi here and n pi in the bracket here, you cannot cancel out. Okay, that is wrong. Why? Because this n pi is in this bracket. Okay, you can only cancel if you have n pi x over n pi, then only you can cancel out, because it is in the same bracket. But as for this one, only this one is in the bracket. Okay, so the next one is apply upper limit minus lower limit. So you will have upper limit minus lower limit. So therefore you will have is equals to, so 2 over n pi sine n pi minus 2 over n pi sine 0. Okay, so by using this one here, sine n pi is equals to 0. Okay, so you can cancel out this one, because this one is equals to 0. Sine 0 is also equals to 0. Therefore, this one is equals to 0. So therefore, your En is equals to, so only this function, 1 over n pi the whole thing squared. So if I factorize this one, then you will have 1 plus negative 1 and plus 1. Okay, so this is your An. Okay, so next we need to proceed with your Bn. Okay, for your Bn here, you are using the same one as before, which is this one, but the difference is this function need to multiply by sine n pi x over n, and this one. Okay, so you need to refer to this formula. Okay, so fx multiplied by sine n pi x over n. So just imagine if you separate the limit wrongly for a node, then your An is also wrong and your Bn is also wrong. Okay, so please make sure your limit is correct. Okay, so for your Bn here, you will have negative 1, 0, x plus 4 sine n pi x, since your L is equals to 1. Okay, plus 0 until 1, 2 sine n pi x dx. Okay, so again here you need to apply tabular method. Why? Because you have a combination of polynomial and trigonometric function. Okay, so your tabular method will be so this one you differentiate and this is integrate. So you are going to differentiate x plus 4, you are going to integrate sine n pi x. Okay, so x plus 4 is equals to 1, differentiate x plus 4, so you get 1 here, integrate sine will give you negative cos n pi x over n pi, because you need to differentiate the argument inside here. Okay, SC, C, negative S. So this is differentiate and here is integrate. Okay, so for the second one here, differentiate 1 will give you 0. So integrate cos, you will have sine n pi x. So negative is still there, so this one will be squared. Okay, so therefore this is your result for the tabular method. Okay, so you will have negative x plus 4 over n pi cos n pi x plus 1 over n pi squared sine n pi x. So the upper limit is 0, the lower limit is negative 1. So substitute limit here. Okay, when x is equals to 0, so you will have negative 4 over n pi cos 0 plus 1 over n pi squared sine 0. So this is your upper limit. Minus, so what is your lower limit? So negative 1. So you will have negative 4 minus 1 will equals to 3. So negative 3 over n pi cos negative n pi plus 1 over n pi squared sine negative n pi. Okay, so how are you going to simplify this one? Again, you need to use this one. Okay, sine n pi is equals to 0, sine negative n pi is equals to 0. So therefore, here you know that, so this one is equals to 0, sine 0 is equals to 0, cos 0 is equals to 1, cos negative n pi you need to replace by negative 1 power n. So therefore you will have negative 4 over n pi minus minus, so plus 3 over n pi negative 1 power n. So this is for the first one here. Okay, so for the second one here, integrate 0 until 1 to sine n pi x dx is equals to, so negative 2 cos n pi x over n pi 1 0. So therefore you will have negative 2 over n pi cos n pi, so minus minus will be plus 2 over n pi cos 0 is equals to 1. Okay, so combine these two answer. So therefore your therefore your Bn is equals to negative 4 over n pi plus 3 over n pi negative 1 power n. So this one here, cos of n pi, so you need to replace by negative 1 power n. Okay, so you will have minus 2 over n pi negative 1 power n plus 2 over n pi. So simplify this one, will give you your Bn is equals to negative 2 over n pi plus negative 1 power n over n pi. Okay, so now you already have your A node, your An and your Bn. Okay, so this is your A node, this is your en here, and this is your bn. So when you have your a naught, en and bn, so you can proceed with the Fourier series expansion. So what is the Fourier series expansion? How to get the Fourier series expansion is by using this formula. Okay, so copy this one first. Sorry, did it again. Copy, so back here, paste. So you need to use this fx. Okay, so therefore your fx is equals to, so what is your a naught? So your a naught is equals to 11 over 2. So 11 over 2 divided by 2 will give you 11 over 4, plus summation of n is equals to 1 until infinity. So what is your en? So you already calculate your en. So your en is equals to this one, 1 over n pi the whole thing squared (1 plus -1 n plus 1). So this en need to multiply by cos n pi x, since your L is equals to 1. Okay, plus, so what is your bn? So this is your bn. Okay, so as you can see for your bn here, this is n pi, this is n pi, so I can just factorize 1 over n pi. So I will have 1 over n pi, so -2 plus -1 power n sine n pi x, since your L is equals to 1. So you got the same answer. Okay, sometimes when you calculate your a naught or your en or your bn, sometimes you can get the answer 0. It's okay. Okay, along the process, although you already did the tabular method, all those things, and you end up your answer is equals to 0, don't panic. There is a case whereby when you calculate for the Fourier series coefficient, it will be 0. Okay, but as for this example here, as you can see, you have all the value of a naught, en, and also, so this is your a naught, this is your en, and this is your bn. Okay, so we are done with another function. So in my next video, we will proceed with how to solve an even function. Okay, so thank you. Assalamualaikum.